The head of NASA confirms 3I Atlas is not natural, and the alien object now moving closer to Earth.
NASA just made a shocking move. They've officially raised 3I Atlas to level 5, the highest alert possible. Scientists are on edge, and space enthusiasts everywhere are asking the same question. What's really going on with this mysterious interstellar object? Here's why this sudden upgrade has everyone worried and watching the skies. Discovery and initial response. In July 2025, a telescope from the Atlas survey in Chile picked up something strange moving across the sky. At first, scientists thought it was just another comet or asteroid passing by. But when they looked closer, they realized this object, later named 3I/ATLAS, was moving way too fast and in a very unusual direction. It wasn't from our solar system at all. It was coming from deep space. As soon as the news spread, astronomers all over the world rushed to take a look. Within just 2 weeks, more than 200 telescopes were focused on this mysterious visitor. It was one of the fastest global responses in space history. NASA's planetary defense team quickly stepped in and made a surprising decision. They gave 3I Atlas a level 5 classification. This was a huge deal, since neither Oumuamua in 2017 nor Borisov in 2019 ever reached that level. This alert showed just how serious scientists were taking the situation. Soon, observatories from every continent joined the effort. Over 4,000 position measurements came in from 227 observatories worldwide. Every single piece of data helped track the object's path and figure out what it really was. Some of the biggest names in space research joined the hunt. The James Webb Space Telescope, Hubble Very Large Telescope in Chile, Spherex, Gemini South, and Palomar Observatory all pointed their powerful eyes toward 3IA/TLAS. They began studying its light, color, and movement in great detail. What they found was both fascinating and puzzling. The object reflected more light than any normal comet, and its materials didn't match anything known in our solar system. It seemed smooth, shiny, and oddly shaped, not what scientists expected from a space rock. The more they observed, the stranger it became. Was it a natural object or something else entirely? Scientists couldn't say for sure, but one thing was clear. 3IA/TLAS had captured the world's attention. For the first time in years, everyone was watching the skies, waiting to see what secrets this interstellar visitor would reveal. Scientists quickly realized this wasn't normal. 5 strange clues proved something was seriously wrong. The Anomaly Scorecard. After weeks of careful study, scientists created what they now call the Anomaly Scorecard for 3I/ATLAS. It measures 5 main things that make this object so different from anything seen before. Every detail added a new layer of mystery and made scientists realize just how unusual this interstellar visitor really is. Most comets move slightly when gas escapes from their surface, giving them a small push. But 3IA/TLAS hardly moved at all. Its acceleration was less than 15 meters per day squared, which is extremely low. To stay that steady, it must have a huge core, almost 5 kilometers wide. That means it is very dense and heavy, strong enough to resist the gas pressure that usually pushes comets around. The chemistry of 3I/ATLAS shocked everyone. Normal comets have mostly water and a little carbon dioxide. This one is the complete opposite. It has about 95% carbon dioxide and only 5% water. This shows it formed in an extremely cold part of space, much colder and farther away than anything in our solar system. No other comet we know has this kind of mix. Then came another surprise. Scientists found nickel, but no iron in its spectrum. That is almost impossible in nature. On Earth, this kind of separation happens only in industrial metal refining, such as the Mond process, which uses carbon gases to separate nickel. A natural version could happen through a rare reaction called nickel carbonyl formation in a carbon-rich area. but even that would be very uncommon. The path of 3. I/ATLAS is also unusual. It travels at only 5 degrees above the plane where all the planets orbit the Sun. By comparison, Oumuamua came in at 33 degrees and Borisov at 44 degrees. This almost flat path allowed astronomers from many observatories to track it easily for a long time. Finally, 3I Atlas began releasing gas when it was still 4.5 times farther from the Sun than Earth, even beyond Jupiter. This early activity was caused by its high carbon dioxide content, and its glowing coma was visible from the very start. Each clue showed the same thing. 3I-ATLAS is not an ordinary comet. It is something truly extraordinary drifting through our skies. Then, during a lunar eclipse, something incredible happened that left everyone speechless. The green glow mystery. On September 7th, 2025, something amazing happened in the night sky. During a total lunar eclipse, 3I-ATLAS began to shine with a bright green glow. The light was so strong that even small telescopes could see it clearly. Against the dark red moon, the comet looked almost electric. Within hours, pictures and videos filled the internet, and scientists all over the world turned their attention to this strange and beautiful sight. Usually, when a comet glows green, the color comes from a molecule called diatomic carbon, also known as C2. When sunlight hits this molecule, it reacts and gives off that classic green color. But when experts studied the light from 3I-ATLAS, they noticed something very strange. There was almost no C2 at all. The comet barely had any carbon chains, yet it was shining greener than almost any comet ever seen. It quickly became known as the green glow mystery. Scientists began searching for answers. One possible explanation was that 3I-ATLAS has a layered surface, with some materials buried deep inside. The missing carbon molecules might be trapped under the surface, waiting to be released as the comet gets closer to the Sun. If that is true, the green light could grow stronger over time as new layers heat up and start reacting to sunlight. Another theory was even more exciting. Some researchers suggested that the glow might come from a rare fluorescing molecule, a substance that shines green when hit by sunlight, even though it is not carbon. This would mean 3I-ATLAS contains materials we have never seen before in any known comet. Whatever the true cause, the effect was breathtaking. The comet's green light lit up the eclipse sky and amazed everyone watching. It was not only a beautiful event, but also a scientific mystery. 3I-ATLAS had done something no other comet had done before, glowing brightly without the usual chemical cause. This moment reminded the world that space still holds surprises, and sometimes even a simple color in the sky can change everything we think we know. That strange green light raised more questions. Now scientists needed answers fast. Testing protocols. As 3I Atlas continued its journey through the inner solar system, scientists began a detailed series of tests to learn everything they could about it. Each test was designed to uncover a new piece of the puzzle, what it is made of, how it behaves, and where it came from. The process became one of the largest international research efforts ever focused on a single interstellar object. The first major study used polarimetry, a method that analyzes how light scatters off dust grains. This helped scientists learn about the size, shape, and texture of the particles surrounding 3I-ATLAS. Early results showed unusually smooth and reflective dust, unlike the rough grains found around normal comets. Next came stellar occultation, a test where scientists measure how a distant star's light dims as the comet passes in front of it. These measurements gave precise estimates of 3I-ATLAS's size and shape, suggesting a roughly rounded body several kilometers wide. At the same time, radio monitoring was carried out to check for any artificial signals. No signals were found, exactly what researchers expected from a natural object. Still, the test confirmed that the comet is quiet on all radio frequencies. The most important work is still underway: spectroscopy. This test breaks down light into colors to reveal the comet's chemical composition. Early data matched some of the unusual findings from the green glow mystery, but the study is ongoing and could reveal even more surprises. The next few months will be crucial. On October 3rd, the comet will pass near Mars, about 0.19 astronomical units away, giving the Mars Reconnaissance Orbiter a chance to take detailed photos. By late October, it will reach its closest point to the Sun, about 1.36 astronomical units, where solar heat may trigger new activity. Then, on November 3rd, it will pass close to Venus, and by March 16, 2026, it will move near Jupiter, only 0.36 astronomical units away. NASA's Juno spacecraft might even attempt a close observation. After all those tests, researchers found 5 key numbers that reveal the shocking truth. 5 critical numbers. After months of non-stop observation, scientists have narrowed down 5 key numbers that define what makes 3I/ATLAS so remarkable. Each number tells part of its story, from how fast it travels to what it's made of, and together, they paint a picture of one of the strangest interstellar visitors ever discovered. 3I Atlas is moving through the solar system at an incredible speed of 68 kilometers per second. That is far faster than anything bound to the Sun's gravity. Its path is hyperbolic, which means it came from outside our solar system and will never return. The speed alone proves it is a true interstellar object, one that entered from the dark space between stars and is now just passing through. The comet's closest approach to the Sun, known as its perihelion, is about 1.36 astronomical units, right between Earth and Mars. This is close enough for sunlight to heat its surface and trigger outgassing, but not close enough to destroy it. As it moves past this point, scientists expect new materials to vaporize, possibly changing its color, brightness, and tail. Measuring its size has been tricky, but most estimates place it between 1 and 5 kilometers wide. That makes it much larger than Oumuamua, but smaller than typical long-period comets. Its large size explains why it moves so steadily, resisting the usual pushes from escaping gases. The mix of gases escaping from 3I/ATLAS is unlike anything seen before. The ratio is around 95% carbon dioxide to only 5% water. This strange balance shifts slightly as it gets closer to or farther from the Sun, showing that different layers on its surface release gases at different times. Finally, its orbit tilts only about 5 degrees from the plane where most planets travel. This low angle gives astronomers excellent viewing opportunities from many observatories around the world. Each of these 5 numbers adds to the mystery. Together, they show that 3I/ATLAS is not just another comet, it is a rare messenger from the deep unknown, carrying secrets from far beyond our solar system. These numbers tell an amazing story, but what do they actually mean for us? Scientific implications. The discovery of 3I/ATLAS has opened one of the most exciting and challenging chapters in modern astronomy. Whether this object is natural or artificial, the results could reshape what scientists know about how matter forms and travels through the galaxy. If 3I/ATLAS turns out to be a natural object, it could completely change how we understand the chemistry of distant star systems. Its unusual mix of gases, especially the high amount of carbon dioxide and low amount of water, suggests it formed in an extremely cold outer disk, far beyond where most comets are born. This could mean that other solar systems, especially those around older or dying stars, can create objects very different from anything found near our Sun. Such a discovery would show that the galaxy's comet populations are far more diverse than we imagined. Some might be icy, others rocky, and a few, like 3I/ATLAS, might come from frozen regions on the edges of ancient systems. Understanding these materials would also help refine exoplanet habitability models, showing how life-building elements such as carbon, oxygen, and water might spread across space. If, however, 3I/ATLAS were proven to be artificial, the impact would be beyond anything in human history. Scientists already have clear testable criteria for this. They are watching for coherent narrowband radio signals, which could suggest communication. They are also monitoring for specular glints, flashes of light that might mean smooth metal surfaces reflecting sunlight during rotation. Other key signs would include steady thrust that doesn't match solar heating and extreme isotopic ratios far outside natural ranges. Any of these findings would prove that 3I Atlas is not just an interstellar rock, but a piece of technology, a sign that intelligence exists far beyond Earth. This discovery stands out from anything before. Let me show you why it's different. Historical context. To understand why 3I Atlas has caused such excitement, it helps to look back at the two interstellar visitors that came before it. Oumuamua in 2017 and Borisov in 2019. Each one changed the way scientists think about objects traveling between stars, but 3I Atlas takes that story to a whole new level. The first visitor, Oumuamua, was spotted in October 2017, but only after it had already passed its closest point to the Sun. Because of this late discovery, astronomers had very little time to study it. It moved quickly, spinning strangely, and showed an odd cigar-like shape. Even more puzzling, it showed unexplained acceleration, as if something invisible was pushing it. Some scientists suggested it might be a fragment of rock or ice, while others wondered if it could be something artificial. But by the time the debate began, Oumuamua had already disappeared into deep space. The second object, Borisov, arrived 2 years later in 2019. It was clearly a comet, with a bright tail, plenty of water vapor, and a chemistry that matched known solar system comets. It behaved just as expected and gave scientists their first proper look at a natural interstellar comet. In many ways, Borisov brought relief. Proof that not every visitor from beyond the stars has to be mysterious or strange. Then came 3I Atlas in 2025, and it changed everything again. Detected early, tracked by hundreds of telescopes, and studied in extraordinary detail, it showed multiple anomalies, strange chemistry, odd movement, and an unexpected green glow. Unlike the brief glimpses of the past, this time the world is ready, watching every step. 3I Atlas represents not just another interstellar visitor, but a new era in how humanity studies the unknown. 3I Atlas taught us valuable lessons. Now we're getting ready for what comes next. Future preparedness. The arrival of 3I/Atlas has shown the world just how important it is to be ready for the next interstellar visitor. This time, astronomers had enough notice to organize a global campaign, but it was still a race against time. The experience is now shaping how scientists plan to respond in the future. The upcoming Rubin Observatory in Chile will play a huge role. Once it begins full operations, it is expected to detect dozens of interstellar objects every year. With its powerful wide-field camera, it can scan the entire southern sky every few nights, spotting fast-moving objects long before they reach their closest point to the Sun. This means the next 3I/Atlas could be found months earlier, giving scientists more time to prepare. Another major goal is creating a rapid intercept capability, a small spacecraft weighing around 200 to 300 kilograms that can be launched quickly to study a new object up close. Such a mission could gather detailed images, measure gases directly, and confirm what telescopes on Earth can only guess. Scientists are also working on clear protocols for future discoveries. The scramble to study 3I/Atlas has shown that speed and coordination are everything. Having a ready plan will make sure the next event is handled smoothly and efficiently. Finally, these same techniques can improve planetary defense. Tracking, modeling, and rapid response, all developed for studying interstellar visitors, are also crucial for assessing and preventing potential asteroid threats to Earth. Even with all this preparation, scientists still can't answer these critical mysteries. Open questions. Even after months of close study, 3I/Atlas continues to hold on to many of its secrets. Scientists have gathered an incredible amount of data, but several key questions remain unanswered. Questions that will shape how we understand this mysterious interstellar visitor. The most immediate mystery is the true size of its nucleus. Estimates range from 1 to 5 kilometers, but final confirmation will depend on the upcoming Mars imaging campaign, when the Mars Reconnaissance Orbiter captures high-resolution photos during the close pass. Researchers are also watching for late-evolved chemical species, gases that may come from deeper ice layers as sunlight heats the core during its closest approach to the Sun. If these appear, they could reveal how the comet formed and what lies hidden beneath its surface. Another major focus is the iron line that may appear at perihelion, confirming whether iron finally emerges after earlier detections showed only nickel. Meanwhile, NASA must still decide whether to proceed with a Juno spacecraft intercept when the object passes near Jupiter in March 2026. Lastly, the long-term trajectory of 3IA-TLAS is still being refined. Each new observation helps map its exact path and where this interstellar traveler will go next. The story of 3I/ATLAS is still unfolding, and every new discovery could rewrite what we know about our universe. Stay tuned, keep watching the skies, and don't miss what happens next.